In this video, we're going to continue to solve by factoring, but not necessarily always on quadratic equations. So this first example, this is not a quadratic equation because in a quadratic equation, the highest power on your x is 2. The highest power on this one is 3. Okay. But as we know, whenever we're trying to solve by factoring, we should start with easy factoring before we even think about the whole reverse FOIL method, right? Or the AC method or anything like that. So when you see this equation, we'll notice that there is a 2 in common to both terms, and there's also an x in common to both terms. So I can pull a 2x out, and I would be left with, well, 2x times x squared is 2x cubed, and 2x times negative 9 gives me minus 18x. And then this right here can be further factored. So I'm going to just leave the 2x out front. And when I see x squared minus 9, right, I'm thinking difference of squares. And that always factors into x plus 3 times x minus 3. So remember, the key is we set any factor that has a variable in it to 0. So not only will we say x plus 3 equals 0, x minus 3 equals 0. Sorry, little typo there. Let me fix that. So x plus 3 equals 0, x minus 3 equals 0, but also 2x equals 0. So everything that has a variable. And then we just solve each of these individual little equations. And in this one, you solve just by dividing by 2, so x equals 0. So here's one where there's actually 3 solutions. There's 3 values of x that if you plug them in to the left side, it'll equal the right side. The example on the right here is already in a factored form, right? It's x plus 3 times this other factor equals 0. So you could apply the zero factor theorem to both of them. But before you do, what you should do is check to make sure that even this factor here can't be further factored. Well, since it's a quadratic expression, there's a decent chance that maybe it can. So what we're going to do is do x plus 3 and then see if we can't factor the 3x squared minus 20x minus 7. Now, one of the rules of thumb that I gave you for, when do you want to use something real formal like the AC method versus just kind of guessing and checking is just, how big are the numbers? How many different ways are there of breaking down your first and your last? Well, the truth is there's not very many ways of breaking down 3x squared nor of negative 7. So I'm just going to guess and check this one. So I'll do 3x and I'll do x. And what I think I'll do here is, how about, let's do plus 7 minus 1. And actually, let me do what I did before with guess and check. I'm going to lightly pencil it in. So I guess I'll represent that by this kind of light, what did I say? Minus 1 plus 7, right? And then we have to check to see if we did it right, which gives me positive 20x, which is not the same as what we have. But the good news is anytime you get the right value but the wrong sign, it's a real easy fix. You just change this to a plus and you change this to a minus, right? And then that'll fix the issue, right? All right, so now that I've done my guess and check, let me clean this up. Erase all the kind of scratch work here. So we know that it turns into 3x plus 1 and x minus 7. So then we set each individual factor equal to 0. So x equals -3 on the left. X equals -1/3 in the middle. And x equals 7 over there on the right. So just like the last problem, we've got 3 different solutions. All right, so here's another one where we've got 3 different terms. It's not a quadratic because x cubed is our highest power, but with these 3 terms, I can see that there is a 3 in common to each term, and there's an x as well. So we're left with x squared minus 3x minus 4. So 3x, and then let's see if this factors further. It certainly does. X minus 4 and x plus 1. And because we have a variable out here, 3x equals 0. So x equals 0 is the solution. X equals 4 is a solution. And x equals -1 is a solution. So 3 different solutions there as well. All right, so the next couple pages in our notes have just a lot of practice problems. These are the types where it's best for you just to do the practice and see how you do. So there's 8 of them. So A, B, C, D, E, F, and G, H. So press pause here and try all 8 of these, and let's see how we do. And then I'm going to, when you press play again, I will quickly solve all these. And if you have questions about these, of course, reach out to me and I'd be happy to walk through some of these with you more carefully. All right, so part A. This is already in factored form, and because it's equal to 0, I can apply the 0 factor theorem right away. So x is equal to 14. And since x plus 4 could equal 0, x equals -4 is the other possible solution. Now on part B, I put these back to back to kind of purposefully tempt you, because this one looks a whole lot like this one. But the big difference is this one was equal to 0 in part A, this one's equal to 28. So it doesn't matter if they gave it to you in factored form. If those factors aren't multiplied to give you 0, then it doesn't do you any good. So you got to multiply it out, get one side equal to 0, and then maybe you can refactor it. So I'm going to FOIL this out. So it'd be x squared. Outside is minus 2x. Inside is minus 5x. And last is plus 10. So we'll subtract 28 so that I can get one side equal to 0. And then, of course, the minus 2x and minus 5x combine to minus 7x. 10 minus 28 is minus 18. And now I can see about factoring this. So I need what is going to multiply to make 18, that's going to add to make -7 as the middle term, and of course that's the 2 and the -9. So x plus 2, x minus 9. Now part C, we've got negative 2y squared plus 72. And so we have one side set equal to 0, which is great. But then we're going to look for, is there anything we can factor out of both terms? Well, certainly a 2 can, but also we want our y squared to be positive whenever possible, so we'll go ahead and factor out a negative 2. So I get y squared in the first term minus 36 in the second term. Now this also can be factored because it's, again, a difference of squares, right? So we know whenever that happens, y plus 6, y minus 6. So we set every factor that has a variable in it equal to 0. So we get y equals negative 6 and y equals 6. Then in part D, we have one side equal to 0 here as well, but there's also definitely things that we can pull out of each term. So each term shares a common factor of 3 and a common factor of x. So that leaves us with 5x squared plus 8x minus 21 equals 0. Now this is one where maybe the AC method would be a good idea because with the AC method, we'd go what? 5 times negative 21, which is negative 105, right? Sorry about my bad handwriting there. Negative 105. Now we're trying to make positive 8, right? So, just kind of going through the list here. Of course, negative 1 times 105 would not work, right? Adding those together gives you way bigger than 8. 2 can't divide in. We could say negative 5 and 21, but negative 5 plus 21 is much bigger than 8. So we're going to have to try something else. We could negative 7, right? Since 21 is divisible by 7, you could do negative 7 times 15. Ah, there we go. Negative 7 plus 15 is 8. And just as a reminder, I know that in these videos, I'm kind of just doing this stuff in my head seemingly, but don't worry about you don't have to have like your multiplication facts for the number 105 memorized, right? Like I don't want to imply that. So like as you're going here, the idea is you can be taking 105 and dividing it by various numbers, right? So when you divide it by 2, okay, that's not a whole number. So you could divide it by 3. Okay, yes, that's a whole number. And so technically I kind of missed one here. I probably should have put negative 3 times 35. So sorry for missing one. But the point is use the calculator to your advantage, right? If 2 doesn't work, of course, 4 doesn't work, but then divide by 5 and 21, right? Divide by 7 and 15, right? So using the calculator to help you is 100% okay here. All right, so that means we have 3x. And oops, I forgot my own rule that I like to follow, which is when I'm doing the AC method or the factoring by grouping method, because I know a lot of parentheses are going to show up, I like to use brackets. So I'll do this. And so this is telling me break the 8x up as 15x minus 7x. So I can factor a 5x out of those first two. And then keeping in mind I want x plus 3 to show up by factoring the second two out, I'm going to factor a negative 7 out of those. So it'd be x plus 3. So then by factoring x plus 3 out, we'll get 3x times x plus 3 times 5x minus 7. Now, we set 3x equal to 0 because it has a variable in it. So x equals 0. We set x plus 3 equal to 0. So x equals negative 3. So add 7 to both sides. So 5x equals 7. And I've run out of space here. So divide by 5 over here. So x equals 7/5. So we've got that solution, and that solution. Now I want to put these two side by side here and make an important note. I set 3x equal to 0 because letting x be 0 is a way of making the entire expression on the left equal 0. I did nothing with the negative 2, right? Because there's no variable there, you don't want to set that equal to 0. That wouldn't make any sense because negative 2 is not the same as 0. So it's only if there's a variable in what you factor out of everything that you're going to set it equal to 0 in addition to your other factors. All right. Here, there's a couple of tricky ones. So we've done definitely some so far that where maybe we have a number that's not 0 on one of the sides of the equation. But you can also have some of your variable terms or multiple terms on both sides of the equation. But the principle remains the same. You've got to get one side equal to 0. And keeping in mind the fact that we like to have our y squared term usually be positive, then the way in which I'm going to choose to get one side equal to 0 is by subtracting 9y from both sides. That way I have a positive y squared term. Of course, we're going to factor not only a y out, but a 3 out, right? Doing our easy factoring. So that leaves us with 2y minus 3. And since both of these factors have variables in them, I'll set them both equal to 0. So y equals 0 and y equals 3/2. So kind of the same story on the other side here, but it has multiple terms. But if I look over multiple terms on both sides, but my 2x squared is positive now, so that means I'm going to kind of want the left side to be the side that has the terms on it, and then the other side to be the side that has the 0 on it. So I'll subtract 3x from both sides. I'll subtract 4 from both sides. So 2x squared plus 9x minus 5 equals 0. And in a problem like this, we could do the AC method, but 2x squared has only one way it can break down. Negative 5 can break down as 1 and negative 5 or negative 1 and 5. So I don't have a ton of possibilities, so I think I'm okay doing the guess and check here. So I'll put in 2x and x, and then notice that it's a positive number here, and it's kind of a big positive number. So my guess would be making a plus 5 where the 5 ends up getting multiplied by 2x. And then the minus 1 on the inside here is probably going to be the way to go. Right? We can double check it. But yes, that gives us the middle term of 9x. So we'll set each of those factors equal to 0. So x equals 1/2. And then x plus 5 equals 0. x equals -5. So just two more examples here. Part G is in factored form, but is it completely factored, right? Can I take this quadratic expression and do better? So we can try that by saying, let's give it a shot. X here and X here. And we want to think about -36, right? So what are the ways of creating -36 by multiplying? But we need these factors that I'm listing to add up to 5. And of course, I think we just found it. -4 and +9. So we set each of these that have variables equal to 0. Those are 3 solutions to that one. And then finally on this last one, just another one where we got to remember not to, or to make sure that we set one side equal to 0 first. So we'll of course subtract 24 first. So x squared minus 5x minus 24 equals 0. So -24, since it's a negative middle term, I'll break it down like this, with the larger absolute value being the positive, or excuse me, being the negative number. And I think 3 and -8 would do the trick. So x plus 3 is 0. X minus 8 is 0.